I hope everyone's doing well. I'm Mr. Ish. Thank you for joining me for this video where we're looking here at an inverted cone problem. An inverted cone is draining at a certain rate. Here we're talking about a volume. When something is draining, the volume of that solid is decreasing because it's a solid which is containing a certain fluid, and that solid being a cone, and it's inverted. An inverted cone is draining at a rate of 1 centimeter cube per second. If the base of that cone is 4 centimeters radius, a total height of 8 centimeters, find the change in the height with respect to time when at time t equals 0 seconds the liquid was 2 centimeters from the top. What are we talking about? You have an inverted cone which looks something like this, and it's filled with a certain solution, and here it is, and that solution is draining. Over time, as its solution is draining, it's decreasing in the volume dimension. The volume measurement is decreasing. You have an inverted cone which has here a radius of a 4, it has a total height of 8. At time t equals 0, the liquid was 2 centimeters on the top. 2 centimeters from the top is where your liquid solution is, whatever it might be. Over time it's draining, so the volume of this liquid is decreasing. How can we address this with regards to what we have over here? For a cone, you know volume is equal to 1 over 3 pi r squared h. If you were to apply the rate of change to it, look at what happened. With respect to your variables volume, radius and height, everything else are constants, you'd have change in volume over change in time is equal to pi over 3, constant push outside, the derivative of r squared would be 2r, and you'd have the radius and the rate items show up. Then you'd have the derivative of h, which would be a 1 because it's the power of 1. You do the power rule, the h variable goes away, but the height with respect to time item comes in. You're looking at 3 items which are rates of change. Now look over here at your question. You're given this right here, 1 centimeter per cube per second. The rate is decreasing, the inverted cone, the solution, the volume is decreasing. So you have this item right here, provided it's 1. You have to find this, but nowhere are you seeing this. I'm not seeing rate of change of radius over time. So we have to somehow get rid of one of these variables. We have 3 variables, 1, 2 and 3, volume, radius and height. We have to keep 2 and get rid of 1 variable by algebraic manipulation, and let's do that before we can start this question. Look here at your inverted cone and think about properties of similar triangles. If I look at something like this, this is what I have. If I were to make a bisecting line, I am looking at this. I have a total height over here which is 8. I have a certain solution which is 2 units from the top, but from here to here I'm just calling that a certain h. I have a new radius and I have a complete radius 4 right here. I have a full radius, full height, small radius, small height. Do ratio and proportion. Small radius over full radius is equal to small height h over full height 8. Solve for r. I have 8r is equal to 4h and r is equal to 4h over 8, which is h over 2. Now I've expressed radius with regards to height, and I bring everything over here. I know now r is equal to h over 2. Bring that into your volume formula without worrying about rates of change and see what happens. We don't need to see this anymore, we'll just erase this. When I look here at the volume formula, I have volume is equal to 1 over 3 pi radius, which is now h over 2, but it's a square, and then h. Volume is equal to pi over 3, I have a h cube over 4. Bring everything together, you'll have here volume is equal to pi h cube over 12. This is now expressing the volume of a cone, getting rid of the radius variable. Everything here is with regards to volume and height. Now you bring the rate of change with respect to this new formulated equation. When you do volume is equal to pi over 12 h cube, which is exactly this written in a different way, you apply the rate of change. What do you have? And I'll bring that for you right over here. You already know radius is equal to h over 2, so we're good with that. Bring it in. You have a change in volume with respect to a change in time is equal to pi over 12 is a constant. It's not affected by the derivative procedure. The derivative of h cube is 3h squared. Then you have the rate of change of height with respect to time. This is what you're determining. Everything else you have. Plug in your items. Something is decreasing with time, it must be a minus value, because if something is increasing with time, it's a positive value. You know something is draining, so the volume of the liquid in that inverted cone is decreasing. It's a minus 1 is equal to pi over 12 3h cubed. You can bring the 3 over here. 3 pi over 12. h squared, you know what the height is. It's not going to be this. Your liquid is topped off in that inverted cone 2 centimeters from the top. 8 minus 2 is equal to h, which is equal to 6. That's what we have. 6 square. This is what we're calculating for dh over dt. Bring everything into play. Minus 1 is equal to 3 pi times 36 over 12. You have here 12 going to 36 3 times. I'll have here a 9 pi dh over dt. You know this is simple math. 36 divided by 12 is a 3. 3 times that 3 is a 9. Solve for your rate of change of height with respect to time is equal to minus 1 over 9 pi. And that right here will be your answer. What will your units be? You know your units are going to be what you're seeing over here, but get rid of the cube because we're not looking at a volume dimension, we're looking at a linear dimension, and it'll be units centimeters per second. Each second your height will drop by a factor of minus 1 divided by 9 pi. You can run this on your calculator. Obviously it's a decimal value. As the volume is decreasing at a rate of 1 centimeter cube per second, your height of that liquid in the inverted cone as it's draining is decreasing by this rate, minus 1 over 9 pi centimeters per second, and the problem is solved. Thank you for watching.